Hey everyone, welcome back. I hope you're all doing well. In this video, we're going to go over the backward pass of the precedence diagramming method. So let's break it down step by step. The backward pass works by calculating late times, specifically the late start, LS, and late finish, LF, for each activity. We go from right to left, starting from the finish milestone and working our way back to the start milestone. First, at the very last activity, we start by setting its late finish, LF, equal to the project duration. For all other activities, their late finish depends on their successors. This means we need to look at all the activities that come after it. To do that, we check for outgoing links from the finish side of the activity. These links can follow either a finish to start, FS logic, where the late finish of the current activity is equal to the late start of its successor minus any lag time, or a finish to finish, FF logic, where the late finish is simply the late finish of its successor minus lag. When an activity has multiple successors, we take the smallest late finish, LF, from all of them. For late start, first, it depends on the activity duration and its late finish time. To calculate late start, we just subtract the duration from the late finish, but we're not done yet. Just like with late finish, we also need to check the successors of late start by tracing the outgoing links from the start side of the activity. If it's a start to start, SS relationship, the late start of the activity is equal to the late start of its successor, minus any lag time. If it's a start to finish, SF relationship, the late start is equal to the late finish of the successor, minus lag. Again, if there are multiple successors, we take the smallest late start from all the possible outcomes. And that's it. Those are the basic rules for calculating late start and late finish times using the backward pass in PDM. All right, let's go back to example 1, where we already completed the forward pass. Now, it's time to apply the backward pass to find the late start and late finish of the activities. For the backward pass, we move from the last activity and work our way back to the first activity. Let's start with activity C. Since we're moving backward, we calculate the late finish before the late start. The late finish of C must be 12, which is equal to the project duration. The reason for this is simple. We don't want to delay the project completion. Delaying C will extend the project duration. Now, if activity C is completed on day 12, it must have started on day 7. We get this by subtracting the duration from the late finish. Next, let's move back to activity B. As you can see, the late finish of B is determined by the start of C. Since C starts on day 7, that means B must finish on day 7. Now, to determine the late start of B, we take its late finish and subtract its duration. 7 minus 4 gives us 3. Following the same process for activity A, we get a late finish of 3 and a late start of 0. Keep in mind that the start of the first activity, which is A in this case, must always be 0. If it's not, then something is off with your calculations. Make sure to check everything carefully. And that's how the backward pass works in a simple network. Now, let's apply this method to a more complex network. This is the example that we have already completed the forward pass. Now, we do the backward pass. We start from the last activity, which is activity D. Since D is the last activity, its late finish must be equal to the project duration, which is 19 days. Subtracting 19 by the duration of 5 days, we get 14 as the late start of D. At this point, we have a choice. Should we go to activity C or activity E next? Let's say we want to do E first. However, the finish of E depends on the finish of C, but we don't know the late finish of C yet. That means we cannot do E right now, so we need to calculate C first. The finish of C is determined by the finish of D. So we take 19 and subtract the lag time of 6 days. And that gives us a late finish of 13 for C. Since C lasts for 5 days, its late start is 13 minus 5, which gives us 8. Now that we have the late finish of C, we can go back and calculate activity E. The late finish of E is determined by both the late start of D and the late finish of C. That means E's late finish could be either 14 or 13. For the backward pass, we always take the smaller value, so we choose 13. It is important to identify all successors by locating all outgoing arrows. Many students make mistakes in PDM calculations because they overlook dependencies with successors. Since the duration of E is 8 days, its late start must be 13 minus 8, which gives us day 5. Note that the start of E does not have any outgoing arrows or successors, so 5 is the only possible value for its late start. Next, let's look at activity B. The finish of B is followed by the start of C, so the late finish of B should be 8. However, we also need to consider the lag time, which is minus 1, so 8 minus negative 1 gives us 9. Since the duration of B is 4 days, its late start would be 9 minus 4, which gives us day 5. But if we take a closer look, the start of B is also followed by the start of E, as there is an outgoing arrow from start B to start E. which is at day 5. Based on this dependency, the start of B should be 5 minus 2 day lag, which gives us day 3. Between 3 and 5, which one would you take? Since we always take the smaller value, the late start of B must be 3. Finally, let's calculate activity A. The finish of A determines both the start of B and the start of E. That means the late finish of A could be either 3 or 5. We take the smaller value, which is 3. Since the duration of A is 3 days, its late start must be 3 minus 3, which gives us 0. It looks like our calculations are correct because we ended up with a late start of 0 for the first activity, which is what we should always expect. That brings us to the end of this video in which we covered the backward pass of PDM. In the next video, you will learn how to use the results from both the forward and backward pass to evaluate the flexibility of activities and identify critical activities. We'll see you in the next video. Goodbye.